Section 2.2, Graphs of Linear Functions. So in this section, we'll graph linear functions, write the equation of a linear function given its graph, determine if two lines are parallel or perpendicular given their equations, write the equation of a line parallel or perpendicular to a given line, and finally solve a system of linear equations. Graphing linear functions. Let's graph f of x is equal to 2/3 x plus 1. So first thing to notice is that this line is in slope-intercept form. And the reason we recognize that is because we can clearly identify that the slope is 2/3 and the y-intercept is 1. So when we want to graph a line that's in slope-intercept form, the first thing we do is we put a point at the y-intercept. So in this case, the y-intercept is 1, so we'll put a point at 0, 1. So on the y-axis, here we are at 0, 1. Now this is really important. We need to start from the y-intercept. So from the y-intercept, we're going to use the slope. Remember, what is slope? Change in y over change in x. Other ways of thinking about that are rise over run or up and over. And we're going to find a second point on the line. So we're going to go up 2 and over 3. So from here at the y-intercept, we go up 2 and over 3 and identify our second point. And then all we have to do is join these points together and extend the line. So that's how we graph a line that's in slope-intercept form. We go to the y-intercept. From the y-intercept, we count off the slope. That gives us a second point, and we join the points together. Let's try another example. Graph f of x is equal to negative 2x minus 1. So again, let's notice that this is in slope-intercept form. Here we have the slope, so the slope is negative 2. Sometimes it's nice to always have the slope written as a fraction to graph, so I'm going to put a 1 in the denominator. And we can see that the y-intercept is negative 1. So we'll go ahead and graph this. So the first thing we do is we find the y-intercept. So on the y-intercept, we go to negative 1, and we mark the y-intercept. Next, we're going to do the slope. So the slope is negative 2. So we can go down 2 and over 1. Or we could go up 2 and over 1 in the negative direction. It really doesn't matter because we're just going to graph the line, and no matter which way you graph the slope, it would result to the same picture. So we have a descending line because our slope is negative. Here's one for you to try. See if you can think about sketching the graph of f of x is equal to 1/2 x plus 3. Now this will be a bit of a review from the last time. We're going to write the equation of a linear function from its graph. So let's write the equation of the linear function shown in this graph. So the first thing we want to do is we want to find the y-intercept. So here's the y-intercept. We can see the y-intercept is 2. And next we want to find the slope. So normally what I would suggest is finding another point on the line. This one is a little tricky because it's not clear to us what another point on the line is. I'm just looking at this graph to see if we can identify a nice point on the line, and none of them look particularly nice. I mean, I can see a point here, but if I think about, well, what are the coordinates of that point? The coordinates of that point would be 1, 2, 3, 4, 5. So this would be 1 2/5 for the y-coordinate, and 1, 2, 3, 4, 5. That would be 1 4/5 for the x-coordinate. So unfortunately, I think that's what we're going to have to do because we don't have any better points to use. And so we would go ahead and say, okay, we'll use then the point slope formula. So here we have one point at 0, 2. Here we have another point, and the coordinates of this point are 9/5, 7/5. And again, if you're not sure how we did that, I was looking at the coordinates of this point. I can see it's between 1 and 2, and I notice that each of the units represents 1/5. And so this is 1 and 4/5 in the x-coordinate, and in the y-coordinate 1 and 2/5. So now we could use the slope formula. So the slope formula would say, okay, we should subtract the y-coordinates. So we're going to have 7/5 minus 2, which is 10/5, divided by 9/5 minus 0. So subtract the x-coordinates, subtract the y-coordinates, and now it's just kind of messy arithmetic. So 7/5 minus 10/5 is -3/5, and 9/5 minus 0 is 9/5. And so what do we have? We have -3/5 divided by 9/5. So this will take you back to some old school arithmetic. That's 3/5 times 5/9. And so if we simplify that, we can see that, oh, the slope is -3/9, or in other words, the slope is -1/3. Okay? So using the y-intercept, y is equal to -1/3 x plus, and the y-intercept is 2. So this would be the equation of that line. So hopefully we don't run into any others that have yucky arithmetic like that one did. Normally you can find a more friendly point that the line goes through. It's just that in this section of the graph, we weren't given a friendlier point than 9/5, 7/5. And finally, let's just review writing the equations of linear functions from a graph. We'll write the equation of the linear function shown in the graph. Let's not do all of them. Let's just do maybe one of them. All right, so let's pick one. Let's do the this orange line right here. Okay, so I can see that it has a y-intercept of 3, and fortunately, the orange line is better than our last example, has friendlier points. If we want to find the slope, it's up 2 and over 1. In other words, the slope is 2. So the y-intercept is 3, the slope is 2, and so this orange line, which is function number 1, would be f of x, y, is equal to 2x plus 3. So now what I'd like is for you to try one. So see if you can try to write the equation of the function 4. So let me just show you that one. It's this line right here. So here's the y-intercept. Find 2 points in the line to find the slope. So it should be pretty easy to find some friendly points on that line. And don't forget that the slope should be negative because the line is going downhill.